Welcome to the 8th lecture on industrial engineering and operations research. Now, in this lecture, we will talk about inventory management. It is very important topic because company's profit depends very much on the inventory. The main mantra is that one has to reduce the inventory as much as one can do. It is said that more inventory a company has, the less likely they will have what they need. It is a quote by Taichi Ono, who has contributed a lot on inventory management and lean manufacturing, etc. Inventory is one of the most expensive assets of many companies. It represents as much as 50% of total invested capital. Operations managers around the globe have long recognized that good inventory management is crucial. On one hand, a firm can reduce cost by reducing inventory. On the other hand, production may stop and customers become dissatisfied when an item is out of stock. So, inventory basically means it may be finished good, it may be in process good, means basically these are the items. Suppose you are making the scooters. Now, if you do not have sufficient number of scooters in stock and suddenly the order comes, then customers will be dissatisfied because they will not have it available. On the other hand, if you take too much scooters in stock, then there may not be demand. So, that means this has to be optimized. That is why the term management, that how you have to do. So, all organizations have some type of inventory planning and control system. For example, a bank has methods to control its inventory of cash. It is not that inventory should be any physical good like scooter, etc. A bank also has to do inventory management. Bank's inventory is the cash. A hospital has methods to control pharmaceuticals and blood supplies. Suppose suddenly there is a need for a patient to provide blood. Naturally, that there should be some blood in stock, but they cannot keep too much blood, otherwise it will be useless. And similarly, medicines, etc. In the shop, sufficient amount of medicine should be kept, but not too much, otherwise the medicines will expire. So, in cases involving physical products, the organization must determine whether to produce goods or purchase them. That also has to be taken some decision, whether this has to be made in house or we have to purchase from outside. Once this decision has been made, the next step is to forecast demand. Okay. You have to understand that what is the demand, accordingly you can decide the inventory. Then operations managers determine the inventory necessary to service that demand. So, basic inventory issues are how much to order, when to order. Okay. That means how many quantities you have to order and when you have to order. So, what are the functions of inventory management? To provide a selection of goods for anticipated customer demand and to separate the firm from fluctuations in that demand. That means separate the firm means firm should be unaffected by the demand fluctuation. Its working should be smooth, it should go on producing the things, it should be go on functioning properly. So, that is why it is very essential that you have to select goods for anticipated customer demand. To decouple various parts of the production process, for example, if a firm's supplies fluctuate, then extra inventory may be necessary to decouple the production process from supplies. That means, if suppliers are having some problem and because of that they are not able to produce the goods in time and I am not getting that thing in time, so my production should not suffer. Okay. So, therefore, you can say inventory may act like a flywheel in mechanical system, just like in the time of lean period, flywheel gives its extra energy and when there is excess energy, flywheel stores. So, similarly, the inventory, if you have something in stock, then it can be useful in the emergency situations and when you have extra production, then thing can be put in the inventory. Okay. To take advantage of quantity discounts, because purchase is in larger quantities may reduce the cost of goods or the delivery. Sometimes you may be tempted to purchase in large quantity, even though your requirement is only 2 pieces, but it is better to purchase a dozen pieces so that you can get discount benefits. And to hedge against inflation and upward price changes, that means it is better to purchase something in the beginning, because after some time, maybe due to inflation etc., the prices may rise also. So, what are the types of inventory? To accommodate the functions of inventory, firms maintain 4 types of inventories: raw material inventory, materials that are usually purchased but are yet to enter the manufacturing process. This inventory can be used to separate suppliers from the production process. So, what we need? Lot of raw material. So, raw material can be kept in stock, and if you have sufficient raw material in stock, then you will not be too much dependent only on suppliers, because if there is some strike in the suppliers company, then also you have something in stock. Another thing is work in process inventory, that is called WIP. Products or components that are no longer raw materials but have yet to become finished products, they are called work in process. So, they are something intermediate type of things. So, WIP exists because of the time it takes for a product to be made, called cycle time. There is one thing called cycle time. Suppose I manufacture some product and it takes 30 minutes. So, 30 minutes will be my cycle time. So, therefore, in between unfinished good is always there, and that is called work in process inventory. Reducing cycle time reduces this type of inventory. Then another type of inventory you may have to keep in the stock, that is for maintenance purpose, for repair purpose, and for operating supply inventory. That means something which is essential for operating the things or machine etc. So, they are called MRO. MROs are inventories devoted to maintenance, repair, operating supplies necessary to keep machinery and processes productive. They exist because the need and timing for maintenance and repair of some equipment are unknown. Sometimes there may be sudden breakdown. So, if you have something in stock, it will be useful. Another thing is that finished goods inventory, which is the most crucial, and accounts people generally consider that as the main inventory. So, this is an end item ready to be sold, but still an asset on the company's books. The final classification of inventory that is used for accounting purposes by manufacturing companies, they count that inventory as the main inventory, because it is finished goods inventory. That means my company is having so much cash, so much inventory in the form of finished products, like that they do. So, now let us discuss something about inventory models and associated costs etc. Inventory control models assumes that demand for an item is either independent or dependent on the demand of other items. Okay. So, they may have these assumptions. For example, the demand for a 4-wheeler car is independent of the demand for 2-wheeler motorcycle. However, the demand for helmets is dependent on the requirements of motorcycles. So, these are the 2 type of inventory models. Now, what are the costs involved in the inventory? So, these are holding, ordering and setup costs. What are holding cost? Means you are holding inventory in your factory. So, therefore, you are basically having some cost. So, holding costs are the costs associated with holding or carrying inventory over time. So, this is the cost of that. And category of holding costs, why we need to have spend money if I keep inventory in my factory. So, one thing is that housing cost, that means I have to provide some house or some place for that inventory. So, if maybe I have to have some go down, and that go down, for that I have to pay rent, is it not? I may have to keep a separate room. Sometimes in some product require air conditioning, so maybe I have to need AC building, AC room, that type of thing also is there. So, holding cost means building rent, or if I have got made, suppose I have made room itself there, okay, I need not keep in the rented place, then also depreciation is there. Depreciation means the value of that room keeps reducing over time. Suppose I got built my room and I spent 5 lakh rupees, let us say its value is 5 lakh rupee today, but after 1 year its value may not be 5 lakh. So, depreciation, maybe if I say that 10% depreciation, then 50,000 will reduce. Something will say that this room is costing now 4.5 lakh rupees only, because naturally the some quality of that house might have deteriorated. So, that is why, and similarly that suppose house has become very old, suppose it is room has become 10 years, then maybe it is not very good condition. So, its value is almost nothing. So, that depreciation is of course for building etc. depreciation generally may not be 10%, it is maybe sometimes maybe only 3-4% depreciation per year, but in some cases of course depreciation can be very high also. Like generally many people consider that computer's life is only 3 years. So, they say that okay, in 3 years you have to recover all the value. So, if you have purchased a computer in 90,000, that means per year depreciation can be 30,000. So, like that. Anyway, so depreciation is another topic that how to calculate, that has to be done very carefully. There are some guidelines, but main point I am trying to emphasize that housing cost will include building rent or depreciation, then of course operating cost. Suppose there is AC in that building, then AC cost will also go there. No? Had the product not been stored there, then there was no need of AC. Then taxes and insurance. So, this cost is generally 3 to 10% of the total inventory value. Suppose the total inventory is of 1 lakh, maybe 3,000 or maybe at most 10,000 generally goes in that housing cost. Then another one is the material handling cost. That means equipment lease or depreciation, power, operating cost. So, anything you do with handling of that material, moving from here to there, or any type of that thing, or maybe if the value itself is reducing of that item, then that also has to be accounted. It is 1 to 3.5%. And then labor cost means receiving, warehousing, security. Okay, labor has to do something, you have to employ a security guard to protect that inventory, that cost will be 3 to 5%. Investment costs, that means borrowing costs, taxes and insurance on inventory. If you are storing, you are paying some premium for insurance, and you are also, your money is also blocked. You might have borrowed some money from others, okay, to maintain that. If you sell, then you will get some money and you can pay back your debt. So, this is 6 to 24%. And pilferage, scrap and obsolescence, that means it is much higher in industries undergoing rapid changes like tablet phones and smartphones. That means over the time it becomes obsolete or it becomes scrap type of things. So, it is 2 to 5% money goes in that also, because some component, something may be out of fashion, and maybe that if you want to sell next year, then you have to take out that component and you have to put the brand new component. That type of thing also happens. So, these are the basically holding costs. And ordering cost includes cost of supplies, farms, order processing, purchasing, clerical support and so forth. That means when you order something one time, then that means you have to pay some amount also. That means not the amount of the inventory, but you have to that means to process that order, see, you have to make some document, something, and other things are there, that are maybe that if you are getting some transportation. So when orders are being manufactured, ordering costs also exist, okay, even if you are doing own manufacturing, but they are a part of what is called setup cost. Setup cost is the cost to prepare a machine or process for manufacturing an order. This includes time and labor to clean and change tools or holders. Operations manager can lower ordering costs by reducing setup costs and by using such efficient procedures as electronic ordering and payment. For example, I have got a 3D metallic printer which is costing about 5 crore rupees, and in that, I suppose you have to make some components. Whether you make one component or you make that 10 components, you have to prepare that machine, you have to put fresh set of powder, and you have to heat that. In that process 50,000 rupees go. So this is called the setup cost, okay. So that way, now inventory models for independent demand, that means we are just telling some basic models, that where independent demand means inventory's demand is not dependent on other demands, okay. So inventory model that addresses two questions: when to order and how much to order. Different demand models are basic economic order quantity model, production order quantity model, quantity discount model. So we will discuss little bit these models. So first we just discuss basic economic order quantity model, EOQ, which is very primitive, but it is a basic one. It will broaden your concept. So for academic purpose, naturally I have to tell you very carefully. EOQ model is one of the most commonly used inventory control technique. This technique is relatively easy to use. It is based on several assumptions. One, that demand for an item is known, reasonably constant, and independent of decisions for other items. Then there is a lead time. The time between placement and receipt of the order is known and consistent. Receipt of inventory is instantaneous and complete, okay. So that means as soon as it is not that I ordered 50 components and each day one component is coming and in 50 days it is complete. I am assuming that those 50 things will come at one go. In other words, the inventory from an order arrives in one batch at a time. And then quantity discounts are not possible. That means it is not dependent that if I purchase more, then I will get cheaper. The only variable costs are the cost of setting up or placing an order, that means setup or ordering cost, and the cost of holding or storing inventory over time, that is called holding or carrying cost, okay. So stock outs, that is shortage, can be completely avoided if orders are placed at the right time. That is my assumption, that there will not be any stock out. So this, if I show you graphically what way that we can order that, this is the time and this is inventory level. So maybe I need, suppose economic order quantity is Q, that means you should order in a batch of Q. So order quantity is maximum inventory level, so that is Q. So 0th day suppose it has come, inventory has become Q. Then inventory is reducing because demand is consistent and constant, each day some items go, and in so many days it will become 0. Again your new another batch has come, so that means order has come and then again it has come down, and then it is usage rate, means it is getting due to demand, okay. So like that it happens that you know that from Q inventory becomes 0 in a continuous fashion, again Q lot comes and then again it becomes 0, again Q items lot comes, again it becomes 0. So average inventory is basically Q by 2. It is obvious. So the graph of inventory usage over time has a sawtooth shape. This is called sawtooth. It looks like a cutting saw, sawtooth shape as shown in figure. Q represents the amount that is ordered. And now if the amount Q is 400 mobile phones, suppose I am a mobile phone seller and I am selling the mobile phones, so all 400 phones arrive at one time when an order is received. Thus the inventory level jumps from 0 to 400 phones. In general, an inventory level increases from 0 to q units when an order arrives. So, that is what I have explained. Now, as demand is constant over time, inventory drops at uniform rate over time as shown by sloped lines. You see that it is dropping at uniform rate. Each time the inventory is received, the inventory level again jumps to q units represented by the vertical lines. This process continues indefinitely over time. So, I have explained everything. Now, the steps for developing EOQ model are as follows. So, develop an expression for setup or ordering cost, that in 1 year how much money you have to spend for setup or ordering, both are same. Or then develop an expression for holding cost, then set setup cost equal to holding cost. Okay. That somehow it happens that optimum inventory will be that in which the setup and holding cost will be equal. So, solve the equations for optimal order quantity. The variables to be used in the model are as follows. Q denotes number of units per order. Q star means optimum number of units per order, that is EOQ, that we have to find. D is annual demand in units for the inventory item, and S is setup or ordering cost for each order. H is holding or carrying cost per unit per year. Okay. So, we have done this type of thing. Then annual setup ordering cost will be what? Number of orders placed per year into setup or order cost per year. So, that will be annual demand divided by number of units in each order will give total number of orders, multiply it by setup or order cost per order. So, it is D divided by Q into S, because S is the setup cost per order, and annual holding cost will be what? Average inventory level into holding cost per unit per year. So, average inventory is Q by 2, holding cost per unit per year is H. So, therefore, Q by 2 into H. So, optimal order quantity is found when annual setup ordering cost equals annual holding cost. That means D by QS is equal to Q by 2H, or 2DS is equal to Q square H, or Q square is equal to 2DS by H. So, therefore, now we say this is the final answer. So, I put a star here, that means Q star, my final answer, or economic order quantity is under root 2 ds by H. So, this is the way that I have done, that means holding cost, but some people, students may say that, sir, why both the cost should be equal at optimum level. So, I am doing it by another method, optimization method for finding economic order quantity. Here what we do, that we write the total cost is equal to sum of the setup cost plus holding cost. So, D by Q into S plus Q by 2 into H. So, therefore, dt C by dq is equal to minus d by q square into s plus h by 2 is equal to 0, or it implies that q star is equal to under root 2 ds by h. So, same answer we get, because this is the dts by dq for condition for maxima and minima, but it is minima only, that means total cost will be minimized. For that purpose, you can double differentiate this thing, d square tc by dq square is equal to 2d by q cube and into s, which is a positive quantity, hence naturally it is a minimum. So, expected number of orders placed during the year and the expected time between orders can be determined. Expected number of orders N will be demand divided by order quantity. So, order quantity is Q star and demand is D. So, therefore, expected number of orders will be D divided by Q star, and expected time between orders T will be number of working days per year divided by N, because expected number of orders are N. So, that will be time between the orders. That is how that it is it goes. Okay. So, this is the expected time between orders in terms of the working days. Okay. In between holidays are there, that we are not counting, because here also we have taken number of working days per year only. Okay. So, now let us give that one numerical example to understand it better. A company that may markets face masks to pharmacies would like to reduce its inventory cost by determining the optimal number of masks to obtain per order. The annual demand is 5,000 units. The setup or ordering cost is rupees 1,000 per order. The holding cost per unit per year is rupees 50. That means if you order that thing and it will come, maybe it is coming from some different city, you have to send some salesman, not a salesman, but maybe some employee of your organization, that purchaseman, and he will bring. So in all that process it takes 1,000 rupees, let us say. That is called ordering cost. So solution is that optimal number of units per order by the formula, it is Q star is equal to under root 2 ds by h, 2 into 5,000 because d is 5,000 into 1,000. 1,000 is the setup cost or order cost, and divided by h, this is the holding cost per unit per year, that is 50. So answer is coming 448 units. In previous example, the company has a 250 working days. Find the number of orders and the expected time between orders T. The optimal order quantity was found to be 448 units. So expected number of orders will be demand divided by order quantity, that means D divided by Q star, that means 5,000 by 448, that means 11.16 orders per year. So round figure answer is 11 orders per year. However, let us consider two cases, 11 orders per year and 12 orders per year. That means you can actually have two cases. So case 1, suppose you give that if the number of orders is 11 orders per year, then annual setup cost will be rupees 1,000 into 11, that means 11,000, and number of quantities per order will be this much. So suppose you got 454.55, but 454.55 mask you cannot take. So say 455 units are set for 10 orders and 453 units are set for 11th order. For this case, the holding cost is equal to for 10 months, it is 450 by 2 into 50 into 10 by 11, and for 11 another month, it is this one 453 by 2 into 50 into 1 by 11. So total cost comes out to be like that, and it is total cost is 22,370.45 rupees. In case 2, if the number of orders is 12 orders per, so then the annual setup cost will be rupees 12,000, number of quantities per order will be 5,000 by 12, that means it will be 416.67. So say 417 units are set for 11 orders and 413 units are set for 12th order. So for this case, the holding cost becomes 417 by 2 into 50 into 11 by 12 plus 4 by 13 by 2 into 50 into 1 by 2. So this becomes rupees 10,416.67, and total cost becomes rupees 12,000 plus 10,000 416.67, and this becomes rupees 22,416.7. Previous one was 22,370.45. So therefore final answer is that it is clearly seen that sum of setup and holding cost is less for 11 orders per year policy. Hence we should procure the inventory in 11 orders. We will have to spend rupees 22,371 only, and expected time between orders will be number of working days per year divided by number of orders placed in a year. That means 250 by 11, 22.73, or approximately 23 working days. So as I said that the total annual variable inventory cost is the sum of setup and holding cost. So total annual cost is equal to setup ordering cost plus holding cost, or TC is equal to D by Q into S plus Q by H. Inventory cost may also be expressed to include the actual cost of the material purchased. In this is only inventory management cost, but if you want to add the inventory cost also, if the annual demand D and the price per mask P are known, then equation becomes this one. So, d by q into s plus q by 2 into h plus p into d. Okay. P into d has been added here. Now, coming to the concept of reorder point, based on the previous discussion, it can now be evaluated how much to order. Now, the second inventory question is when to order. So, simple inventory model assumes that receipt of an order is instantaneous. It is assumed that a firm will place an order when the inventory level for that particular item reaches 0 and that it will issue the order items immediately in the same day. But in practice, the time between placement and receipt of an order, called lead time or delivery time, can be as short as a few hours or as long as months. Sometimes it may take months actually to get. The when to order decision is usually expressed in terms of reorder point. That reorder point will tell how many quantities you should see in your inventory, then you can order. So, reorder point is given as ROP is equal to demand per day into lead time for a new order in days. So, it is in terms of the units, that suppose reorder time is 30 units. As soon as you see that inventory has dropped down to 30 units, place an order. So, this equation assumes that demand during lead time and lead time itself is constant. When this is not the case, a safety stock is also needed. So, reorder point with safety stock becomes ROP is equal to expected demand during lead time plus safety stock, and the demand per day is given by D is equal to annual demand divided by number of working days in a year. Okay. Now, another one is the production order quantity model. In the previous inventory model, it is assumed that the entire inventory order was received at one time. Sometimes the firm may receive its inventory over a period of time. Such cases require a different model. Here it is not instantaneous. You see that here you can get, for example, you have already seen that here your order comes immediately. So, inventory has become 0, all of a sudden it becomes Q. But this situation may not be many cases. Sometimes you keep making something and it keeps on getting consumed also. So, that point also has to be addressed. So, there can be two situations when inventory continuously flows or builds up over a period of time after an order has been placed, or when units are produced and sold simultaneously. Under these circumstances, we take into account daily production or inventory flow rate and daily demand rate. Under these circumstances, daily production or inventory flow rate and daily demand rate are considered. So, this is a production order quantity model, and we use following symbols. Okay. Q is the number of units per order, as we have been always telling. H is the holding cost per unit per year. This is also symbol we used. Now, P is the daily production rate. Small p is the daily production rate. Daily this much is produced. And D is the daily demand rate or usage rate. And T is the length of the production run in days. That means when one batch will be made, then how many days production will continue. So, maximum inventory level can be there, total production during the production run minus total used during the production run. So, because T days it is operating, so P into T will be the total production and D into T will be the total expense, that D per day this much demand is there. So, in T days DT will go. So, however, Q is equal to PT, because naturally we are ordering that Q. So, we have planned as per that Q is equal to PT. So, therefore, T is equal to Q by P. Okay. So, that means, so by that you can get the answer that in these days you have to produce this one, T is equal to Q by P. So, maximum inventory level will be P Q by P minus D Q by P. That means, maximum inventory becomes Q1 minus D by P. Now, maximum inventory never reaches Q, because you are producing slowly and also it is getting consumed. So, it becomes 1 minus D by P. And here if you put of course, if D is in that period, if there is no demand, then matter is different, then it will become Q only. Suppose all of a sudden production rate is so infinite, it almost takes 0 time, then it will be Q only. You can say production rate infinite becomes a special case of that simplified model. So, annual inventory holding cost or simply holding cost will be what? Maximum inventory level by 2 into H. So, this time it will not be Q by 2 into H, rather it will be Q by 2 into 1 minus D by P into H. So, optimal order or production quantity is same thing when inventory is consumed as it is produced is found when annual setup ordering cost equals annual holding cost. That was a simple way to do that. Otherwise, you can do by differentiation way also, but I am doing that. I am making the holding cost equal to ordering cost. So, ordering thing is that D demand S by Q number of orders. Here that S is the setup cost, D by Q is the number of orders. So, D by Q into S, and this becomes equal to Q by 2 into 1 minus D by P into H. So, we got like that. So, if you equate both D S by Q, Q by 2 1 minus D by P into H, and therefore, you bring Q this side, Q square is equal to 2 ds H divided by 1 minus D by P, or you get QP star is equal to under root 2 ds H 1 minus D by P. Okay. So, we can give that one numerical example. A company forecasts that its automobile parts will be 5,000 units next year with an average daily demand of 4 units. However, the production process is the most efficient at 8 units per day. Hence, the company produces 8 per day, but uses only 4 per day. The company wants to solve for the optimum number of units per order. The setup or ordering cost is rupees 1000 per order. The holding cost per unit per year is rupees 50. So, all the data has been given. Annual demand D is equal to 5000 units. Setup cost is rupees 1000 given. Holding cost is equal to rupees 50 per unit per year. Daily production rate P is equal to 8 units daily. Daily demand rate is 4 units per day. So, if this data is given as I have written here, then in the formula we just have to substitute the values. QP is equal to under root 2 ds H 1 minus D by P. So, 2 into 5000 into 1000 divided by 50 into 1 minus 4 by 8, that means 633 units. The difference between the production order quantity model and the basic EOQ model is that effective annual holding cost per unit is reduced in the production order quantity model because the entire order does not arrive at once. So, some items are made by, suppose this is one extra exercise problem is there, but this problem I can tell you in my next session also. So, that is why right now I am stopping at this stage. Thank you very much for that.